Thanks. Welcome back, everyone, and thanks for being here. Man, it's very bright. My name is Zoltan Olah, and I'm an engineer and co-founder at Percolate Studio. And we're a digital studio operating out of SF in Melbourne. We bring products to life from idea to conception, and our specialty is in front-end design and engineering. And we work almost exclusively in JavaScript with some Objective-C and Swift for mobile. Now, we were early adopters of the Meteor framework and have put apps into production now that serve thousands of concurrent users regularly. And over the years, we've seen some confusion on what Meteor is, how it works, what it's good at, and as well as what it's bad at. So my goal here is to have you walk out today with a clear idea of how you can best leverage the technology, and frankly, when you should consider using something else. So one common cause of confusion that we've seen is when Meteor is compared one-to-one with other technologies. And I think this is flawed because feature for feature, there is really nothing else that's quite the same. So Meteor is often thought as a JavaScript version of Rails, but I'll show you why I think that's not quite the case. So Rails and Meteor both come with a command line tool, and they're both used to build web applications. And that's about where the comparison ends. Rails enforces the MVC pattern for building traditional request-response-based web apps that run on the server. So it takes some very old and very well-understood patterns and makes it super streamlined to implement those patterns easily. Instead, Meteor apps are rich real-time, single-page apps where most of the magic happens on the client. So the problems and the solutions here are very new and very different, and typically too open-ended to effectively handhold developers through them, like Rails does with MVC. So Meteor instead just gives you some well-integrated building blocks, and how you want to use them is really up to you. So as an example of something that ships with Meteor is Atmosphere, which is a package repository and a command line package installer. So that's similar to NPM. But it provides this functionality specifically for Meteor apps. Now, Angular and React are fantastic front-end libraries. So Meteor ships with its own, called Blaze, which integrates really tightly within the platform. But you can also easily use Angular or React or Famous if you prefer to use that for your front-end instead. Now, Firebase is a hosted database service that provides real-time change feeds. So Meteor actually includes this functionality built in through its live data package. So it's not accessed as a service. Finally, Ionic is a mobile app component library and an app generator that allows you to easily build the front-end part of a Cordova app. And whilst Meteor doesn't provide any pre-built mobile components, it is able to, with one command, build a Cordova app for iOS and Android out of your web app. And so we think of Meteor as a JavaScript platform rather than a framework. It turns out most of the JavaScript ecosystem already contains the pieces that comprise Meteor. However, gluing these together and making sure they work properly is a difficult and time-consuming undertaking. So typically only the most advanced teams with the highest budgets are able to pull this off really well. And once you've finished sweating it out and putting all the pieces into place, you're only then ready to start work on your actual app, which was the whole point to begin with. So Meteor's goal is to get you up and building your modern real-time app as quickly as possible. So once you unwrap the packaging and read the instruction manual, you're really all set to go on building your app without any need to put the foundational pieces into place. And when you're ready to deploy into production, Meteor provides tools to make this trivial as well. So I want to touch briefly on how Meteor actually works, because I think it's a little bit mysterious. So at the heart of Meteor lies Tracker, which is a small library that implements reactivity. So reactivity is the term used by the framework to talk about how data propagates throughout the stack sort of automatically. And so the end-to-end reactivity that Meteor is so famous for is all done with Tracker. And the term magic is I often hear associated with Meteor, But once you learn Tracker, the magic suddenly vanishes, I think, and the tricks become quite obvious. So to put it simply, if you understand Tracker, you'll understand Meteor. So let me show you how it works. This is the only code that I'll have in the presentation, so let's dive in. Reactive var here is simply a reactive variable that we assign to light, and we initialize it with green. Now, the key line here is this console.log, where we get the value of this reactive var, and we print it to the console. Now, the special piece of magic here is the tracker.autorun call, which wraps its call back. And whenever any of the reactive dependencies that are within that function change, it simply reruns the entire function. So further down here, you can see I set the light to amber, and then I set the light to red. And the results in the console are going to be the light is green, amber, and red. And even though there's only one console.log call there, you'll see that code is executed multiple times. Really, really simple, right? So imagine now, instead of doing a console.log there, I simply write some data out to the DOM. And instead of me manually setting the light, as I've done, imagine I wire it up to a WebSocket, and I just set the light to whatever data arrives from the WebSocket. If I did that, suddenly I'd turn the WebSocket into a reactive feed straight into the DOM. So this is really the foundation of Meteor. And I sort of want to bring it back into context, into how this looks in an actual Meteor app. And so one of the magical things about a Meteor app is that your code runs both on the server and the client. And so this is how data flows through the system. And I've colored in these boxes in green, which use the tracker library to propagate changes to the DOM. So first, some data arrives on the wire from MongoDB, and that hits our publications mechanism. And that filters the data that arrives from MongoDB and only sends through the WebSocket to the client the data that's relevant. And so there's a subscription part of the client code that's listening to that data. And what that will do is once it arrives, using Tracker, as I outlined before, it'll push that out to the DOM, right, reactively. And now, as the user is interacting with the app, maybe they click some buttons, they fill in a form, that hits this part of the stack called a method. And why I've colored these boxes in blue is because this is some of that code that actually runs on the client and on the server, right? And why is that really cool? Well, turns out what we get when we have code that runs on the client and server in a full stack framework like this is that we get this magic thing called latency compensation or optimistic updates in other frameworks. So as the user interacts with our app, our methods run, and they modify data that's already on the client, and this reactively feeds straight back into the DOM with very little delay, right? So the user feels like this app is just really snappy and it's super fast. Now what Meteor will then do is propagate those changes through the WebSocket, and that exact same code will run, but this time against the database. And it'll do any authentication checks that it'll do, it needs to do any validation. And then if it's successful, then everything's great. It turns out that that really fast update that happened on the client, nothing else needs to happen. Now, if something happens here, if there's an error or a validation failure, then Meteor's reactive system will automatically back those changes out and reset the client to what it was before the user made their change. Of course, you get a chance to inject any error messages and handle that gracefully. But all that is done for you out of the box with very few code repetitions, which in other frameworks you often need to do. And so over the last 3 years of working with Meteor, we've heard some common complaints and misconceptions. And by far the biggest complaint that we keep hearing is that Meteor is insecure. So people believe that you can write directly to the database from the client, probably in part because of how those updates are done in the RPC mechanism. So whilst this is true, straight out of the box, you simply need to remove 2 packages from the default install to stop this behavior. And I think the authors of the framework made this decision so that the most trivial example apps can be written with fewer lines of code. But I personally think that this was a questionable decision, as it's arguably more useful to show an example app, in an example app, how the pub/sub mechanisms work, rather than just hiding it away. So with that, I'd like to set the record straight and say that Meteor is not an insecure framework, and rally the authors to remove these defaults from the standard install. So operational transform systems allow people to collaborate by editing the same fields together. So Google Docs is a really good example of a system like this. And because Meteor's reputation is that of a real-time system, folks often mistakenly believe that Meteor does OT. And this is not the case, actually. Meteor's real-time system works on the document level rather than the field level. So it's not an OT system, like Share.js, for instance. The other thing that Meteor cops a lot of flack about is why the heck it ships with its own package management system. God knows we need less fragmentation in the JavaScript package management ecosystem. But apart from the fact that Meteor blends client and server code, a simple biggest reason for a new packaging system is that the existing ones don't handle multiple versioning that well. So node modules, for instance, work great on the server, where multiple versions can coexist side by side, multiple versions of packages. But on the client, we have a very different story. So we not only don't want to increase the payload that's shipped to the client by including multiple versions, but some libraries actually just don't work together. They conflict. So React is a great example. So Meteor went and built a semver-based package format and a constraint solver that automatically figures out the set of packages that your app needs based on their dependencies. So you don't end up with these kind of horrible conflicts and a very manual sort of conflict resolution process that can be quite time-consuming. Now, a glaring omission from Meteor's docs, I think, is the presence of a router, which is usually the first thing people look for when considering a JavaScript framework. So Meteor does, in fact, have a router that the community built. Chris Mather from Evented Mind built it, called Iron Router. And that's what most people use. So if you're looking for a routing solution, go and look up Iron Router. I really think Meteor should link to it from their webpage. I don't know why they don't. Finally, a fact that's not often spoken about is that the server-side version of your app actually runs on top of Node.js. So when you create a production build using the Meteor build command, what pops out is a complete minified Node application. So you can run this on the platform of your choice, or just run it with a single Node command. And people often don't realize that Meteor apps can also consume NPM modules as well, directly from NPM. Finally, the last misconception I'm going to talk about is that you can only use MongoDB with Meteor. A lot of people think this. And because fundamentally a Meteor app is a Node app on the server, you can use any database drivers or modules that exist in the Node ecosystem. So you won't have the tight integration that MongoDB enjoys right now, but you won't be any worse off than if you picked some other framework to run on your server. Now, as with any promising new technology, there's going to be some hype, and Meteor is not immune from this. And with that, it's also important to realize that it's no silver bullet. So there are some applications that we don't use it for, and we also think there are some areas within the framework that deserve some attention. So if you're building a high-traffic content site, don't use Meteor. In fact, probably consider not building a single-page app. You might want to stick to a traditional server-ended app with a small JavaScript payload that you can stick a caching layer in front of. Because at the end of the day, your focus when building this kind of site is minimizing load speed and server-side resource usage. So in an attempt to improve developer experience, which is a core founding principle that Meteor abides by, they load all of your script files in the app into a global namespace. So that means you don't need to require and import different parts of your app. And from our experience, this is a questionable decision. Although development time is accelerated at the beginning, it requires extreme levels of discipline to keep your code base namespaced and organized. And it just doesn't grow that well as your team and the code base grows. Thankfully, I think the Meteor team are looking into adopting ES6 and with it the new module system, so I'm hoping that this part of it will be improved. Currently, the build system lacks the flexibility to split your code into multiple files, so it builds one large JavaScript bundle for the client and ships this out. So it means you can't progressively load parts of your app, like the settings page or the admin part that perhaps your user doesn't need on first load. So in practice, we haven't found this to be a huge issue. We host our JavaScript bundle on a CDN, and thankfully it gets delivered quite quickly. But if you're targeting really fast loads on mobile, where every byte counts, then that might be a consideration for you. And then finally, the tools and methodologies for debugging performance on the server side are still really young. And I don't think this is a Meteor-specific issue. So streaming live queries are still a relatively new database phenomenon. They only came to Rethink DB quite recently. So the part that Meteor does where it analyzes the oplog traffic and then filters that and turns it into data on the WebSocket is what I'm talking about here. And so the internal implementation of this is pretty complicated, and you need to have a pretty solid understanding of it to do any performance tuning on this live query side of things. And the tools are still fairly young, and so you might have a hard time kind of debugging that. So again, I think we're seeing some movement to make that easier. And so certain apps, though, I think are a perfect fit for Meteor. And for us, it's difficult to imagine not building these apps with Meteor. So highly interactive, rich client apps that are driven by real-time data, basically. Apps that run on mobile and desktop with the same code base. Basically, any app that's built for human communication and collaboration is going to be a great fit. And these kind of apps all have one thing in common, which we call a living interface. And that's where you never need to hit the refresh button, because the information on your screen is always up to date with the database, thanks to some sort of live query-driven backend. And so if you're looking to build an application like this with a living interface, we think Meteor is a really good choice. And again, once you start using these type of interfaces, like Trello, for instance, or Google Docs, it's really hard to go back to hitting the refresh button again. So finally, I wanted to speak a little bit about how we use Meteor and how it helps us. And really, there's no other framework or set of glued-together technologies that provide the real-time querying and optimistic updating mechanisms that Meteor has out of the box. And it simply doesn't exist. So the fact that we get this from Meteor is a really big deal. Next, we get a standardized platform, right? So we do a lot of projects all the time, different verticals, and it's really useful to be able to just dive right in and know where everything is and know how this complex platform sort of fits together. And so you can be really productive, even as a new developer that comes onto a project, because you can find everything really quickly. So this is also one of the things that people love about frameworks like Rails and Ember, the standardization and consistency. And as I said, because one of the founding principles of Meteor is developer experience, it turns out that developing in Meteor is really, really fast. So we can be super productive and build high-quality projects really quickly. And for this reason, Meteor is also super well suited to rapidly prototyping these type of modern collaborative apps. And if nothing else, we would use it just for prototyping. But it turns out that some of these prototypes naturally evolve into production, and that's totally fine, because we've shown over the years that that Meteor is perfectly capable of handling production loads at scale. And that wraps up my whirlwind demystification tour. I hope that was able to give you some clarity, and that you consider trying out the framework if you haven't already. So JD's up next to talk about Sandstorm, which is actually a perfect place to host your internal Meteor apps. Thank you.